Here's number 4. So there's a ball A that'll roll across this table until it hits ball B, and it'll send ball B flying off this table. And ball B will have a displacement from the base of the table to wherever it lands, and this is ultimately what we need to solve for. So I'm going to start by saying what's positive and what's negative. I'll say that right is positive. I'll say that down will be positive. I'll say left will be negative, and then up will be negative. And it also tells us a bunch of information. It tells us that the mass of ball A is 0.1 kilograms. It tells us that the velocity of ball A is initially at 1.4 meters per second. So I'll say VA1 is 1.4 meters per second. It tells us that ball B's mass is 0.5 kilograms. And it tells us that ball B is initially at rest. So VB1 will be 0. It tells us that after they collide, ball A will have a velocity of 0.7 meters per second backwards. Since we said that left is negative, VA2 is going to be negative 0.7 meters per second. And VB2 is what we're going to need to find in order to find this displacement. To find VB2, I'm going to use the conservation of momentum equations. It looks something like this. It'll be MA VA1 plus MB VB1 is equal to MA VA2 plus MB VB2. And all this equation is saying that the initial momentum of ball A plus the initial momentum of ball B is going to be equal to the final momentum of ball A plus the final momentum of ball B. So we said that VB1 is 0, so I'll cross that out. And I'll write this with numbers. So MA is 0.1, VA1 is 1.4. This is going to be equal to MA is again 0.1, VA2 is negative 0.7, and I'll add this to 0.5 VB2. So this will be 0.14 is equal to negative 0.07 plus 0.5 VB2. I'll add 0.07 to both sides, and we'll get 0.5 VB2. It's going to be equal to 0.21. I'll divide both sides by 0.5, and VB2 will be equal to 0.42 meters per second. Now to solve for the displacement, I'm going to write two equations, one for y and one for x. In the y, it tells us that the balls are 1.2 meters above the ground. So delta y will be 1.2 meters. They'll have acceleration due to gravity, which will be 9.8 meters per second squared. And v in the y is going to be 0, because we're assuming that this ball B will be launched purely horizontally, because ball A is only moving in the x direction. So it'll only apply momentum in the x direction from ball B. And since it won't have any y velocity, it'll be 0. And we're going to solve for time, and we're going to use this time in the x equations. So I'll write this equation. It'll look like delta y is equal to vyt, which is 0, plus 1 half gt squared. So we'll get 1.2 is equal to 1 half of 9.8 t squared. When solving for t, you get t is equal to 0.495 seconds. And we're going to use this number to solve for the displacement. Solving for the displacement, so delta x is what we want to find. We know the time that this took for it to fall to the ground, which is 0.495 seconds. We know the initial velocity of the x, it'll be VB2, which is 0.42 meters per second. We also know the acceleration of the x is going to be 0, because gravity doesn't work in the x. Now we can write the same equation we use in the y. We'll have delta x is equal to VB2 t plus 1 half of at squared. Since we said a is 0, that cancels out. So we'll get delta x is equal to VB2 is 0.42, and t is 0.495. And we'll get a delta x is equal to 0.21 meters. And that there is your final answer. Thank you for watching.